Hey there, Mr. Weaver here, and this is Topic 8, Lesson 3, Positive or Negative, Increasing or Decreasing. After this lesson, you need to be able to describe when a function is positive or negative, and you need to be able to describe when a function is increasing or decreasing. You'll know you're successful after this lesson if you can indicate an interval in either interval notation or as a compound inequality, determine when a function is positive or negative, and determine when a function is increasing or decreasing. In this lesson, there are 4 words that you need to know. So, positive, negative, increasing, decreasing. And you need to be able to keep them separate based on what's happening in a graph. So first we have positive. Positive is when the function, so the graph, is above the x-axis. Negative, on the other hand, is the opposite of that. It's when the function is below the x-axis. So those 2 words are describing the location of the graph at certain times. Our other 2 words are increasing, so that's when the function is going up or has a positive slope. Don't get that word positive confused. So if you're reading the graph left to right, increasing is where the graph is going up. Decreasing is the opposite, where the function is going down, or at that point would have a negative slope. Again, please don't confuse that word negative slope with a negative function. So increasing is going up, decreasing is going down. Before we look at some examples, let's look at positive or negative in a slightly different context. So here I have the ocean, and on it I'm going to put the axes as if this were a graph. So you can see right now that the surface of the ocean is about where the x-axis is. If we had a dolphin here and it swam through the water and then jumped out of the water and then back in, we have a couple different things that are happening here. So in terms of positive or negative, we're going to base that on the surface of the water, which is the x-axis. So when the dolphin is in the water, it's below the surface, those are times where it would be negative. It's below the x-axis. So the dolphin started negative and then jumped out of the water, and then once it's back in the water, it's negative again. The time that it is out of the water is positive. It is above the axis. So you can see here it started off negative, then at some point it switched to positive, then went back to negative based on where it was located above or below the x-axis. Let's look at some graphs without context. And here we're going to need to identify the interval, so our boundaries, like we saw with average rate of change, for when they're positive and negative. So let's start with positive. First, I'm going to indicate here where the axis is. So above that line is positive, below that line will be negative. So positive is just that part that's above the line. I want to know when is it positive. So it starts at x equals 0. That's when it is now above the axis. It stays above until about that point, which is around x equals 13. So we'll say that it ends at x equals 13. So for this, our interval that we're going to need to write, we're taking what we did in average rate of change, but backwards. So here we know the start is 0 and the end is 13. We're going to write the interval. So it started at 0, ended at 13. and x was between those two numbers. When you are dealing with positive, negative, and later with increasing and decreasing, you need to use the greater than symbol. It does not have the line under it. That indicates at those specific points, it's actually not either positive or negative, and later it's not increasing or decreasing. So we're just going to use that greater than sign for every inequality in this lesson. We also could write it with interval notation, with 0 and 13 telling where it started and ended. Because we use just the greater than symbol, it is parentheses. And if you remember in the last lesson, they were brackets and the symbol was a greater than or equal to. The greater than symbol just has a normal curved parenthesis. Now, I'm not going to use interval notation for the rest of this lesson because I don't want you to get it confused with a coordinate. So I'm going to write it as an inequality for the rest of my answers. Now let's look at negative. So negative is when it's below the x-axis. Here, our negative starts around there, which is about negative 13, and it ends at 0. So just like before, we're going to take where it started and where it ended and say that x was between those two things. So our interval where it's negative is negative 13 is less than x is less than 0. Now it's your turn. Pause the video. When is this graph positive and when is it negative? Let's check. You should have found these intervals. My guess here is if you only got one of them correct, it was the negative. So the negative is below that line. It starts at about negative 4.5 and it ends at about 0.5. So negative 4.5 is less than x is less than 0.5. For our positive values, there are two places here that are positive. So it's positive when it's less than negative 4.5 and when x is greater than 0.5. If you notice here, there were arrows on our graph that indicate that it's going to keep going positive. Since we don't know where it ends, we only put x to one side. We don't know what the other boundary is. So if we don't know where it ends and they don't tell us otherwise, we can just assume that it's going to keep going and it will go forever in that direction. Now let's use our same dolphin situation to think about increasing and decreasing. So again, I'm going to put our axes in so we can kind of see how this would look on a graph. Here's our dolphin. Here's the same path that we had before. If this dolphin is swimming along, when it's increasing or decreasing, we are thinking about how it moves. Is the dolphin going up or down? So it's swimming along and it starts to go down. It is decreasing at that time. Then it swims back up. It's increasing. Swims back down. It's decreasing. Then it swims up, getting ready to jump out of the water. So it's increasing at that point. Then it starts to fall back down to the water and it's decreasing again. So anytime the graph is going down, it's decreasing. Anytime the graph is going up, it's increasing from that time. There are times when the dolphin here or your graph is not increasing or decreasing. That is when there is zero slope. So if the dolphin was swimming perfectly horizontal, or if your graph is a flat line, there is zero slope. So actually, any time that your graph switches from decreasing to increasing, or from increasing to decreasing, there's a point where it is zero. So all of those would have zero slopes, and that's an important thing that you're going to learn in future math classes, For this lesson, we're just going to focus on increasing and decreasing. So let's look at a graph. How can we tell when things are increasing or decreasing? So in the first example, we have this U-shaped graph here. It's going down first, and then it's going up. So it's decreasing, then it's increasing. So I'm going to start with decreasing. It goes down until it reaches that very bottom. So when it gets to the very bottom, that is at x equals 0. That's when it switches to start going up. It's decreasing everywhere before that. And we don't know where it starts decreasing, so we're only going to put one boundary. So we're going to say that it's decreasing anywhere less than 0. So x is less than 0. Increasing, on the other hand, it starts increasing at 0. So again, we don't know when it stops increasing. We know when it started at 0, but we don't know when it stops. So anything after 0, it's increasing. So it was decreasing before 0, increasing after 0. We would have these two inequalities. One thing I want you to notice, they start and stop at the same x value. So decreasing stopped at 0, increasing started at 0. And that's going to be true for all of the graphs that we're going to look at. Now it's your turn. Pause the video. See if you can figure out the intervals of when this graph is increasing and when it is decreasing. Let's check. Increasing was from 0 to 2. So the graph is going up, starting at 0 and ending at 2. Decreasing, there are two places where the graph is going down. So it's decreasing before 0 and again after 2. If we look, it starts off decreasing until it gets to 0, which is our x is less than 0. Then it increases until x equals 2. So it's increasing between 0 and 2. Then it's decreasing again, and we don't know where it stops decreasing. So it's decreasing for the rest of the time after 2. X is greater than 2. Now let's look at a couple examples where we want more than one thing to be happening at the same time. So first, let's look at positive and increasing. It needs to be both positive and increasing at the same time. So let's start with positive. So positive has to be above the x-axis. There's only one tiny little part that is positive. The rest is negative. And it ends about that spot. So we're done finding our positives. Now we need to see where is it increasing. Well, from wherever we can see, it is going down. So that whole part that we can see, it is decreasing. So based on this graph, positive and increasing never happens. From what we can see, it's positive, but during that time it's decreasing. Our other one is negative and decreasing. So we have a lot of place where it's below the x-axis, and that whole time it is decreasing. So we need to make our interval. Where does it start? Where does it end? While it's decreasing the whole time, it doesn't start being negative until -9. So then it's decreasing after that, and since we don't know where it ends, we're not going to put the other boundary. So our interval here would be x is greater than -9, meaning anytime after -9, it is negative and decreasing. Now it's your turn. Pause the video one last time. figure out your intervals. When is the graph negative and increasing, and when is it positive and decreasing? Let's check. You should have found that it's negative and increasing between 2 and 8, and it is positive and decreasing when x is less than -4. Here's how we get that. So first, again, start with your positive and negative. It is negative below that line. And I want to know when it's increasing, so it decreases first, then increases, meaning it's only negative and increasing between those two dashed lines. So what interval is that? It started at 2, it ends at 8. So our interval then would show x between 2 and 8. For positive and decreasing, positive meaning we want it above the x-axis, decreasing is going down. So on the left side there, we have it decreasing and positive. That stops at -4. So while it's still decreasing, it stops being positive at -4. So our positive and decreasing is when x is less than -4. Once it gets past -4, it's still decreasing, but now it's negative, so not what we want. The key here, if there are more than one thing, they both need to be happening at the same time. So double check them separately, but make sure they both are happening over the interval that you want. In this lesson, we learned about positive or negative and increasing or decreasing. In almost every graph, there are going to be intervals where the graph's either positive or negative and or increasing or decreasing. So positive and negative refer to where the graph is in comparison to the x-axis. So where is the graph located? When the graph is above the x-axis, it's positive at that time. Like the dolphin, when it jumped out of the water, it was above the surface. Whenever the graph is below the x-axis, it's negative at that time, like the dolphin that was below the surface. Increasing and decreasing refer to the motion in the graph, and you can determine that by looking at the slope. So when you're reading the graph from left to right, if the graph is going down, having a negative slope, then the function is decreasing, like when the dolphin was swimming deeper. If the graph is going up, having a positive slope, the function's increasing, again, like if the dolphin was swimming upward. We also saw in the last few examples where we had combinations of things, of positive or negative and increasing or decreasing. If you come across examples that tell you two things, just know both of them have to happen at the same time in order for that to be true. So after this lesson, do you now know how to indicate an interval, either in that interval notation, which we didn't really use because it looked like a coordinate, or as a compound inequality? Do you know how to determine when a function's positive or negative? And do you know how to determine when a function is increasing or decreasing? If you're not sure about these things, go back and look at some of the different examples or how it related to the dolphin to help deepen your understanding of the concept. And that's the end of lesson 3 on positive or negative, increasing or decreasing.